Welcome guys, congratulations. We are in the middle parts of our lesson. We almost halfway done. Wow, can you guys believe that? We learned a lot of things so far. So more interesting topics on the way. Okay, so this unit, we're gonna talk about the electricity and magnetism. Very familiar topics, but little tricky. So you guys need to pay attention really well. Okay, so the first section, we're going to start very lightly. I'm going to introduce the terms we're going to use for the rest of this unit. Okay, so we're going to start with a magnet, right? You guys already know what the magnet is, right? One side is a red, one side is a blue, right? One is a north and one is a south, and then you play with it when you guys were young, right? And also we're using the magnets daily basis. Like if you go to somewhere and then buy the magnets, right, for the some place, right? So if you go to where? London, right? So you probably buy the magnets and then you come back home, and then where you guys gonna put the magnet? In the refrigerator, right? So it sticks there. Why? What's the reason? Why it's there? Okay, so that's the magnet. So we're going to talk about the magnet first. So the poles are placed in the magnet to which magnetic materials such as iron filings are attracted. They are near the end of the bar magnet. Of course, the pairs of the equal strengths, and the one side is the north and the other side is the south, right? Like poles repel and unlike poles attract. That means if you put the north to the north, it repel to each other, north to the south. What's going to happen? It'll attract each other and eventually just stick together, right? So that's a magnet. So magnets attract strongly only certain materials such as iron, steel, nickel, cobalt, which are called ferromagnetics, okay? So not all the metals are attracted to the magnet. So these are the materials that attracts to the magnet. Magnets have a magnetic field around them, which is the region in space where their magnetism can affect magnetic materials. So magnetic fields can be described using magnetic field lines. So we're going to talk about the lines a little bit later. Okay, so here it is. These are the lines. Okay, there are two magnets are placed close together. So opposite poles and same poles, right? So their magnetic field will start interacting. Right? So interaction produces force causes the magnets to move if they are free to do so. Like a pole repels and opposite poles attract. So always the magnetic field line from the north side to the south side, right? You see the lines, they are all attracting each other. You see that they are connecting each other, right? The both sides, they are having the arrows out of the north side, so they are the same poles, so they are repelling from each other. So lines of the force around the north and the south pole join together if it is opposite, right? If they are the same, they are pushing parts apart. So magnetic field line point from the end pole of the magnet all the way back around the south, right? That's how we form the magnetic field, right? Always start from the north to the south. The magnetic field lines never cross over each other or touch. They never, okay? So one of the popular kind of question, right? If you have the magnets, they put the compass around it, and then they see the needle, right? So the dark side is always the north, right? That has to be away from the north pole, right? If we're heading to the south, it has to attract from each other, right? So I see more often on this kind of test question than this. So magnetic field is strongest where the field lines are closest. So that's what we're talking about. If it is closed, that means they have very strong magnetic field, right? If they are apart, further apart, right, that means they have smaller. So magnetic field lines can be plotted and their direction determined using the plotting compass, right? Good. So ferromagnetism, okay? So ferro is like iron. Okay, a long time ago, we used the ferrous instead of the iron. So many magnetic materials are described as ferrous. Alloys are made by melting different metallic elements together. some resulting. The resulting material ferrous if it contains the iron. That's why it's the word from ferrous. Okay. Steel is a ferrous because the steel is the alloy. Alloy is the substance that mixes with the two or more different kind of the metal because the steel is the alloy of the iron and the carbon. Okay, because it contains the iron, so this is the ferrous. Okay, brass is the copper and a zinc, or example of non-ferrous material because it does not have the iron. It's not. So it does not contain any iron, so the brass is non-magnetic. Brass is also the alloy of the copper and a zinc. Now, the word induce. Induce means the temporarily, right? We're trying to make the magnetism. It's not naturally, okay? But forcefully, we're trying to. So magnetic materials can be magnetized by induced magnetism. So we're forced to make the magnetism. They can be magnetized by striking them with a magnet, ring them in a magnetic field, or putting them inside of the coil with a direct current through it. So there are multiple ways we can do it. Okay, they can be demagnetized by hammering them, heating them, or putting them inside of the coil with an alternating current through it. That means once it magnetized, because this is a temporarily, this is not a permanent, we can always, right, demagnetize the opposite way of what we did. So what's the theory behind? So each atom in the magnetic material acts as a small magnet in an unmagnetized object like this, right? The atomic magnets do not line up. It's all different direction. They point in the random direction. In magnetized object, the atomic magnets lined up in a group called domain. So it's all lined up. Right? Then we say this is magnetized. If it is all domains are non-lined up, it's all over the place, it's heading to all different direction, we say this is unmagnetized. So we're going to talk about the difference between the permanent magnet and electromagnet, right? Magnetic materials can be permanently magnetized, right? This is called magnetically hard. Okay, hard means permanent. It's not hard to unmagnify. Okay, so steel is a hard magnetic material because it is difficult to magnetize, but once magnetized, it is difficult to demagnetize. Once we become magnetic, it is hard to come back. Okay, therefore, steel is often used to make permanent magnets, such as a bar magnet. Okay. So bar magnets is the permanent, it's always, right? It does not lose the characteristics of the magnets, right? Because it is made out of the steel. Then permanent magnet is an object made from the material that is magnetized and creates its own persistent magnetic field. For example, is a refrigerator magnet is used to hold the notes on the refrigerator door because it's always magnets, right? It's not losing their magnetism. Okay. Then magnetic materials that are only temporarily, right, magnetized are called, right, magnetically soft. Hard was a permanent, soft is the temporarily. Iron is a soft magnetic material. It is easy to magnetize. It is very easy to do it. Unlike the steel, it is easy, but loses its magnetism easily as well. Iron is often used to make a temporary magnet, such as the electromagnet, right? Electromagnets is an example of the temporary magnets. Okay. An electromagnet is a type of the magnet which the magnet field is produced by electric current. If the current is applied, it shows the magnetism. If it's away from the current, it just comes back. It does not have the characteristic of the magnetism. Okay? The magnet field disappears when the current is turned up. Electromagnets usually consist of wires into the coil. So example is for lifting cars in the scrap yard. right? So they put the current, they can use the magnetism, the lifting up the heavy car. When the current is gone, right, that's not working anymore. So just to turn it in the current for lifting up. So if they don't have to use it, they just turn it off the current, and then it does not have the characteristics of the magnetism. Okay, so this is just the basic of the magnets. So along this unit, right, we're gonna add up a couple more information on top of what we learned today. Okay, so I will see you guys next time with the electrical quantities. So we're gonna talk about the electrical quantities next time. So we're gonna build up more, get more information on top of this. Okay, so I will see you guys next time.